My name is Shabnam Irfani. I'm the lead program manager on Windows Embedded Quebec. And sorry, we're starting a few minutes late. We were frantically trying to get my demo machines projecting, and everything worked fine this morning, and now nothing works. So hopefully gods of demo will be with me in about half an hour or so. Today's talk is about Windows Embedded Quebec. Thank you for coming. I know it's the last talk today, and I'm actually happy because after suffering all the horrors last night in Universal Park, I had some chance to recover. You know, being one of the few girls there, I was the subject of attack from all the zombies and, you know, blood-sucking creatures, so I needed some time to recover from that. Okay. So I'll talk about the objectives of this talk for a few minutes, why I'm giving this talk to you. And I'll talk briefly about our roadmap, what Windows 7 and Windows in general brings to the embedded space for embedded devices. I'll talk about Quebec product goals, scenarios, the developer experience on Windows Embedded Quebec. And then toward the latter half of the talk, I'll do a deep dive into the image build tools and all the developer scenarios that Quebec enables. And hopefully when my demos show up, I'll show you our developer tools as well. So the objective of this talk really is to share with you some of the reasons why Windows Embedded is attractive to OEMs and embedded space in general. And this is a very common question that I get. You know, what's the value of Windows? Why should anybody use Windows Embedded product to build their devices? And finally, the second question that we have gotten quite a bit at the booth is what's the future for Windows Embedded product line? And that's what I'm going to talk about today. And this is more about the future products that are coming up. And one of the reasons we're sharing these plans with you today and sharing our decisions is really to hear your feedback and perception of the product. So feel free. I will allocate some time at the end to hear your feedback, comments, and questions. And if you'd like to talk some more about it, I'll be available at Ask the Experts session. One of the common questions, I added these slides in the last couple of hours because we commonly got a question at the booth asking, you know, what is Windows Embedded? What's the difference between Windows Embedded Quebec, you know, compared to CE? What kind of devices does Windows Embedded go in? So I added a couple of slides to just give you some background on what this product is and where it fits in the Windows Embedded product family. So in the family, there are three products. Windows Embedded Contact, also known as CE. It's a very small operating system. It goes into smaller devices. It has very good power management, native real-time support. Windows Embedded Quebec is a Windows 7-based componentized operating system that has compatibility with Windows 32-bit or 64-bit applications. And finally, Windows Embedded POS Ready is a pre-made custom version of Windows that's more suitable for enterprise point-of-service devices. Now, what is the value of Windows Embedded Quebec? Why do people choose Windows Embedded Quebec for devices? Now, as I mentioned, you can use Quebec or Windows Embedded family. The current version in the market is XP Embedded. You can use this operating system to build your own custom Win32-based operating system that gives you the same level of Windows 7 features, or in case of XP features, and application compatibility, same kind of drivers, and you can build this operating system on off-the-shelf, you know, PC hardware if you want. So you can have very fast time to market. If your device doesn't require a lot of custom hardware, this would be the product to pick. A few notes here. There's no native real-time built into Windows Embedded. However, there are partner solutions available. So if you have needs for, you know, soft real-time, you can use the partner solutions. And another advantage is you can take existing Windows applications and do some dependency analysis, and they will run on the custom image that you build for those applications and for your device. There's also a fairly large developer community that you can take advantage of. So the cost of developing your device is cheaper because you don't have a need for specific, embedded skills for your application development necessarily. And finally, if your device is going to be deployed in an enterprise-like environment, it integrates very well with existing Windows server infrastructure, and you have pretty much functional parity compared to desktop. So in a lot of scenarios, this is a competitive advantage, and in some scenarios, it's not needed. So where it's not needed, CE is another option, and if it is needed, Windows Embedded is a great option. Now, it's amazing to see in how many different device types this product has gone. Kiosks and thin clients are, one of the largest market segments where this product has been deployed and used for. But it has gone into point-of-service ATM machines, gaming machines. If you visited Las Vegas, a few of them are. Some of the gaming machines there are running Windows Embedded. Digital signage in the airports. Automation in medical imaging, MRI devices, and so on and so forth. Now, one of my favorite device types is the Martini mixer that we actually are still looking to get a version for our lab, and we'd be happy to test it for you. So if you're building such a device, please let me know. Okay, so let's talk about Windows Embedded Quebec high-level scenarios. If you think of a device, the life cycle of device development, you first obviously need to build an OS image for your device and build an application for it. And you have to go through a set of rigorous engineering steps to achieve that. You need to have a set of developer tools. Sometimes you need to support a multi-developer environment. You need to integrate with configuration management. Then you need to maybe integrate third-party applications and play the role of a system integrator with hardware and software. And then finally, you have to deal with a lot of testing, debugging, troubleshooting across all layers, across hardware, BIOS, operating system, and application, and these days services and live mesh and Windows Azure and all that. So it gets pretty complex for an embedded device developer. And our product attempts to address all these different developer needs through various tools and scenarios that it supports. The second part is well, when you're building a device, there are very device-specific scenarios that regular Windows doesn't necessarily support. So for example, you build an industrial automation device, and you always want to know what operating system image it's running. So you want to prevent writes from persisting across reboots and have the perception of a read-only device. Or if you're building a hotel kiosk, right, where you're providing internet terminal services, when a guest leaves, you want to make sure the changes they made to the device is discarded just by a reboot. So our product enables these scenarios. And in addition, you can use our product to build smaller footprint Windows images. We support flash booting from removable media. And because it's a componentized version of Windows, you can pull in the stuff that you really need for your device scenarios and for your application scenarios and leave the rest out, which means you will have lower servicing costs at the end of the day. There will be fewer things to maintain, right? And your reliability is increased because chance of failure is decreased. Now, thirdly, after you get your device going, you need to get it out there in the field, right? So once the device is built with the applications and all the drivers and everything, you need to first get it out of your development environment into your factory, be able to manufacture thousands of it if needed, and then deploy those manufactured devices to the field. And once they go to the field, you need to be able to service them, to rev the image, to deploy some security updates possibly, or some application updates, or in some cases, OEMs want to have the flexibility to sell services or sell optional components to their end customers. And Quebec, in Quebec, we have thought through many of these scenarios, and we've worked closely with our customers and used feedback of our customers like you to enable many of these scenarios. Now today, I'm not going to have time to talk about all the 4 quadrants of this product. I'm going to focus mainly on the top 2 and talk mainly about the developer experience and what it takes to build an application, what build environment, what developer environment is available to Windows embedded developers, how they can take their applications, put it on their devices, work with the hardware developers, do rapid prototyping, and finally meet the specific device requirements that I talk about. But before I go there, I want to spend a few minutes on new and exciting scenarios that the technologies you have heard about in this conference enable on embedded devices. Now, there are lots of these, and there are so many great talks in this conference that have gone into depth. But specifically, I wanted to call out a few of these on embedded and point out how these technologies enable new device scenarios for various device categories. And this is based on feedback that we have received from our customers. So we've all heard about Windows Azure and all the new online scenarios and services that it enables. Now, this is perfect for devices. Let's imagine you're building a mobile thin client, right? And you enable all these devices and access, let's say, to all the data storage that Windows Azure provides. And Windows Azure basically makes it easy not only for desktop developers, but also for embedded developers to enable these things for their embedded devices. Similarly, for Live Mesh, if you look at Live Mesh, there are specific scenarios for devices, for data syncing, for identity management. And I often talk to customers who want to build, let's say, mobile thin clients or handheld devices using Windows Embedded that talks to cloud computing and talks to their back-end services. They want to create new business models. And with all these infrastructure that Microsoft is building, devices can go to the next level of connectivity scenarios. Now, another interesting aspect, especially in Windows 7, is introduction of native web services APIs. And for embedded, this is important because a lot of devices have footprint constraints. They're built using compact flash or on flash or on USB keys, and it's expensive to have 16 or 32 gigs of compact flash to accommodate all the code that's needed to support .NET and all its dependencies. So with the fact that native web services APIs exist that interoperate with any SOAP stack is great, because that means you can have a device with a fairly small footprint that can access all these online services. So that's really important for Windows 7. It's something that was not possible before. And since Windows Embedded Quebec is going to be based on Windows 7, it will automatically inherit a lot of these features and make them available to embedded developers. Now, another feature is graphics remoting, RDP7. And there was a great talk today that talked about how presentation virtualization in RDP7 enables new presentation remoting scenarios. So let's imagine a thin client that you put in a data center, right, that has to act maybe as a voice over IP device, right, and connect to a backend server to access some line of business applications. Now, with older versions of RDP, this experience was not very seamless. The media streaming had some issues. There was no two-way media streaming, and overall the virtualization experience was not exactly like desktop, especially when it came to glass and things like that. So with RDP7, a lot of these problems have been fixed, and basically a new experience is possible with RDP7 in terms of graphics remoting. Now, power management is another interesting aspect. Windows typically has been known to be a power hog for embedded, and that has been a problem, especially when it comes to mobility. Now, I wanted to call out a couple of new APIs in Windows 7 that as application developers you can use to optimize power for your embedded devices. So specifically, the register power setting notification API and timer coalescing APIs. can be used to manage power. And there was a talk actually earlier. If you haven't watched it, I really encourage you to go watch it. And it really shows how you can use these APIs to, first of all, improve the experience of your application when power states change, and also change the timer settings so you can maximize the idle state on your CPU, which at the end of the day saves power for you. One feature that I'm very excited about for embedded is basically the sensor development kit. It helps you write context-aware applications. And on embedded, this is pretty important. Embedded devices, think of a POS device or an industrial controller. They're often connected to peripherals and sensors. And by sensor, I mean things that can detect temperature or location, or the amount of ambient light or sound or presence or movement, right? And in previous versions of Windows, it was very difficult to really install all these devices, read the inputs, go through I/O, compile all the outputs. There was no real-time guarantee necessarily. And then finally make a decisionary application based on the inputs you were getting. With sensor development, all of this activity is streamlined, so there's easier access to all the incoming data, and the application can easily get all the data from the sensors and react. So a very common a very simple example is you can easily write an application using sensor development on your mobile thin client that senses the ambient light and changes the screen brightness. So if somebody has a mobile thin client, walks outside, and it's too bright, right, the screen can get dimmed. So much better user experience compared to before. And obviously multi-touch and Surface SDK, I hope you've played with Table out there. You see that what kind of new possibilities it opens up. And finally, audio improvements in Win 7. It started in Vista and actually now has continued through Win 7. It adds a lot of value. So audio streaming, glitch-free, and all that is enabled. So you can build better, media devices or voice-over IP devices that deal with audio. So a couple of examples. Let's say kiosks, right? I categorize based on feedback from the OEMs that we're already working with where these features apply. So kiosks can take advantage of the power management. Oftentimes, if you have thousands of kiosks, right, they end up using a lot of power if they're always on. But they need to be always on because what they're displaying always needs to be on. Or there's no way to really manage the power states right now on previous versions of Windows Embedded if an interactive user is interacting with the application. So the machine always stays on. Now with Windows 7, you can actually have control over that. So you can have different power states on your kiosks to save power overall and write your applications so it would subscribe to power state changes notification APIs. And if there is actually interaction, it stops the power state change until the interaction stops. This is also pretty important in industrial automation. Imagine a factory that has thousands of controllers. If all of these controllers can go into idle state more often, the factory will probably save lots of dollars on the power consumption. To give you an example, I think there was a talk today by Mr. Ben Ravani that talked about MSN Operations Center and how they ended up saving a lot of dollars by just manipulating the power state of the servers. Now, multi-touch, well, I don't know if I need to say much there. It starts a new generation of interactivity with kiosks. Now, same thing on thin clients. And by thin clients, I'm talking about both mobile and desktop thin clients. And I've talked about it quite a bit. Medical imaging, same thing there. And one interesting aspect of Quebec for medical imaging is the fact that it supports 64-bit, which enables support for large image sizes and or the large address space that's required for manipulating large images that, let's say, an MRI machine or an X-ray machine often needs to manipulate and store. Industrial automation, I talked about power management. Now PowerShell is another version or another feature in Windows 7 that enables a really nice remote management and scripting environment for industrial automation devices. So let's say most of the controllers, they're headless devices. They don't have any they may barely have any type of sophisticated management infrastructure, and managing these devices often is a problem, managing and monitoring them. So with PowerShell, a lot of new scenarios open up. That is footprint efficient, it's scalable, and also fast for embedded. Now gaming. One of the gaming requirements, it's actually a legislative requirement, is to ensure that the data on the disk of a gaming machine, and by gaming I mean, let's say, a gambling machine or a gaming controller, is not changing. So something like BitLocker would be very useful in that scenario. It helps guarantee that across reboots, first of all, only trusted code is loaded, and if something has tampered with the operating system code, loading stops right there. So if you're going through some kind of regulatory review, something like a feature like BitLocker would be very useful in that space. And finally, my favorite device in a martini mixer, right? Multi-touch is great. You could just like point and pick your martini type, and you could even integrate with Windows Azure. So I can go and download my favorite martini recipe, and if my 8 o'clock martini is getting late, it can send a notification to me and wake me up, right? Okay, so let's go a layer deeper now. We have talked about all these cool developer technologies that enable nice scenarios. Now, how do we actually take advantage of these things, and how do we build our OS image? So if you think about, I was really thinking hard about what's a good device development lifecycle model for embedded devices. And I've worked in embedded space. I used to be an embedded, actually Linux developer, and for about 12 years, and then I joined Microsoft. And it's really hard because depending on what company and the size of the company you go to, the life cycle is different. So I put together this really simple model just to explain some concepts here. If you think about it, an embedded device is initiated with the device concept. So somebody comes up with a really cool idea. Oh, we need a martini mixer. And from there, really two trains of efforts start. One train is the software development effort, where they start looking at, what kind of UI do we need? What kind of application do we need? What kind of drivers do we need? And what kind of embedded specific things do we need for a martini mixer? Does it need to be a read-only device, or does it need to boot from a hard drive? Can it tolerate certain things? And then a second train of thought starts on the hardware design, right? First, people start looking at the form factor. What should it look like? Should it be like a single screen, or should it have touch, or another form of user input? And then they start looking at, hardware engineering aspect. What should a board, what kind of heat tolerance it should have. And this goes all the way up and down into, BIOS and then the hardware design, the peripherals, the sensors, and the controllers. And in fact, both software guys and hardware guys, on multiple occasions, they interact and they influence each other, and they kind of move their designs in parallel. And at some point when they reach maturity, they go into an integration phase, at least in my experience, where they start running the operating system and their applications on top of the hardware. And then from the integration phase, they may go back into the hardware and software design, quite a few times until they get it right and the device is ready for production. And all along this process, there are a lot of changes that go into software and go into hardware, and there is need for rapid prototyping in multiple disciplines. Somebody wants to try a new driver, right? And you could argue whether it's hardware guys who write drivers or software guys, depending on your religion. I put it in hardware, but it could be software. On both sides, they need to test and try out each other's output, right? So there is rapid need for rapid So there's a big need for rapid development and rapid prototyping throughout the cycle. And these are the concepts that Quebec has tried to optimize in our developer toolkit. Okay, so let's talk about the experience during the software development. Now, Quebec Toolkit itself does not provide anything specific there, except that you pretty much can leverage the existing desktop technologies and environment. So I talked about all the Windows 7 technologies and APIs that you could take advantage of. But I also want to mention that you could just use Visual Studio 2008, the one you have, or the upcoming versions of it, with the add-ons, with the integration with .NET 3.5, with Silverlight. You can use Expression Web, DirectX, Direct3D, all these technologies that are available on desktop on regular Windows 7 are directly applicable to Quebec. So you can reuse everything there pretty much. Now, the catch here is that because Quebec provides embedded specific features, when you write your application, you need to be aware of certain embedded needs. For example, if your device needs to be read-only, we have features that that support that scenario. Now, if your application needs to save some persistent data, with Quebec, you need to be aware of that. So you need to, in your application, you need to disable write filters, and I'll talk about that in a few minutes, and then persist your data. Otherwise, across reboots, your data will be lost. And you need to also be conscious of the boot media that's being used on your device. So if you're booting from USB, for example, or you're booting from compact flash, you need to be aware of your writes. In general, embedded devices run on less RAM, on smaller flash chips or compact flash, and they also have weaker or slower CPUs compared to desktop. Somebody told me that on average, embedded devices trail the latest desktop technology by about 5 to 7 years. I'm not quite sure how true is that, but my point is, when you're writing your application, keep in mind that if this is going on an embedded device, right, it's not going to have all the resources that's available on a typical, multi-core desktop. So be conscious of your memory consumption, of the speed, the boot media, and the hardware resources in general. Now, power management obviously is an issue on a lot of embedded devices as well. Now, in Quebec, we support specific embedded device scenarios. So the one scenario that I talked about was to make devices read-only. And we have technologies to achieve that. These are called enhanced write filter, file-based write filter, and registry filter. And they also have native public APIs that application can use to control them. The way enhanced write filter works, it's basically a kernel driver that intercepts all the writes and redirects them to RAM or to a specific partition on the hard drive. So as Windows is working, writing temp files, or maybe your user is browsing, downloading ActiveX controls, and so on, all these writes normally go to your Windows partition, which means over time, your image has changed from what you installed on the device, and those changes are not controlled. Now, with enhanced write filter technology, all those changes go to RAM or a partition that can just be disposed or saved if you choose to do so. And all you need to do is reboot, and you're back to the original factory state. Now, often that's problematic. So if you have an application that actually do need to save some legitimate changes to the hard drive or to the boot media, we recommend file-based write filter that you can use to exempt certain files and folders from being redirected and discarded. And finally, registry filter provides the same mechanism. It caches the whole registry into RAM, and so changes are not saved. But if you do want to save some registry keys, you can configure registry policy, registry filter to allow certain registry keys or hives to actually be written to persistent media. Now, when you're servicing your device, applying updates or saving data like I talked about, you need to be conscious of these write filters and manipulate them in your applications. Now, we support booting from removable media. Oftentimes, embedded devices need to be booting from CD or DVD or a USB key. VHD boot is another technology that we think will be very useful for embedded. And finally, embedded devices often need to have their own user look and feel, right? You don't want to have necessarily the Explorer shell that you see on regular Windows. So you can replace the shell with your own custom application. And there are facilities in Quebec and Windows, actually, to suppress all the notifications that come up during operation of Windows. You can have sliders for controlling UAC noise. And also, there are ways to brand the Windows image that you're building with your own logo and replace certain splash screens or out-of-box experience of Windows. So especially for embedded, we're enabling and making these operations easier because we know it's a big need. And finally, we're providing very lightweight management infrastructure. It's called Device Update Agent. It can run on your box. It's very lightweight. It doesn't consume a whole lot of RAM and flash space or hard drive space. And you can configure it to access a server, download a script that tells it what to do. And what to do could be go get this update and install it, or just reboot my device, or check this registry key and put the output on that network share. So you could have very simple management and monitoring scenarios with DUA, but certainly it's not an enterprise scale management solution. DUA is only for very simple embedded specific management scenarios. Now, in terms of hardware, what does Quebec provide the software developers so they can work well with their hardware engineer counterparts? Now, we do support x86 and 64-bit platforms. We do support UEFI support for 64-bit, and the product will include the latest drivers for the latest embedded platform. So as you're building your image, you don't need to go chase all these drivers if you're using a specific embedded VIA platform or the Atom. So all of these will be included in Quebec, and you can easily access them. And in terms of design goals, we are trying to get Windows small and componentize it in such a way that it will be feasible given the hardware trends moving forward. So our design goal is to have a minimal image size that fits well into a 512 megs of flash and runs in 512 megs of RAM. And it's fit for running on embedded x86 and x64 processors. And obviously, Quebec will provide access to all the Windows drivers. I think in the last count, there are something like 15,000 drivers in box that are just available for you to use. And if there's a need for developing drivers, we support the same driver development kit, UMDF and KMDF model that is supported on desktop. Okay, so now let's talk about the integration phase. Now you design your hardware, you got your application running. How do we get your application on your operating system? You need to build your operating system using two pieces of information. One, what kind of device role you want to have, what kind of device attributes you want to have. Do you need the browser? Do you need one of the write filters, for example? And finally, when you look at your application, you need to do dependency analysis and figure out what chunks of Windows your application actually depends on, and make sure those are included in your operating system image before your device is finalized. So we recommend Microsoft's sysinternal tools for dependency analysis. They're a set of great tools, and we're also in parallel looking at optimizing and providing additional tools that help with the dependency analysis problem. So these tools can be used to actually find out what binaries, what COM APIs, what registry keys are being used by your application, how is your application accessing the file system, and based on that, make sure that you create the right directories in your image, and what APIs are being accessed. So once you identify all that, you map that to our packages, and we have tools in Quebec Toolkit to do that. And After that, you can use any of the common installer technologies to get your application or your driver onto a Quebec image. And this is a difference from XP Embedded, for example. In XP Embedded, developers had to go through a fairly grueling process to componentize their own application or some third-party applications that they wanted to get. And that was very difficult, especially for drivers. So we're changing that model. It was not necessarily saving a whole lot of footprint at that time. And in Quebec, it's not going to be as important. So we're enabling people to just install their apps using common installer technologies like MSI or batch files or scripts or whatever you desire. And finally, we're changing our toolkit to not only enable advanced developer scenarios that are needed for embedded, but also we're adding tools that enable rapid prototyping and addition of functionality to pre-built images. And that's also an improvement that we're making to Quebec compared to XP Embedded. Okay. So I gave you an overview. Now we're going to go and do a deeper dive into the technical concepts of Quebec and what the image build model is like and what the toolkit looks like. I'll show you the rapid prototyping experience that I've been talking about and so on. And hopefully I'll get my demos up and running. Okay. So there are several new concepts in Quebec. So Quebec design, if you're familiar with XP Embedded, Quebec design there are a lot of new concepts in it, and the thinking is different. So first new concept is that we have a new entity called Embedded Core. Right? So that's a bootable, minimal operating system that you can just use to get started. Compared to XP Embedded, this is different. In XP Embedded, the OS was fully componentized. There were about 1,000 components. But the problem was, because of the dependency relationship between Windows components, there was no point in going that deep. Because on average, even a minimal image would need to include almost 50% of those components just to be bootable. You always need a kernel. You always need a file system. Most of the time these days, people need networking stack. You need a set of drivers to be functional. So if you have to have all of these, why bother the developers with componentized versions of them only to make them go through a pretty grueling experience to put everything back together? So hence the Embedded Core was born. And I'll go into details of what Embedded Core is like and what it contains. So on top of Embedded Core, we'll have feature packages. And then we package our embedded enabling features, the right filters that I talked about. And that goes on top of eCore as well. So let's walk through the image build concept. As I talked about, the first thing people usually do is they decide what kind of third-party software or applications or internal applications they want to build and put on their devices. So they have to do dependency analysis. And based on that, they decide what kind of features they need. Now, another aspect is they look at the type of device markets that this device is going into and the hardware, and they decide what languages and drivers are needed for this image. Then they pick their feature sets and Embedded Core, the embedded enabling features. And finally, they go into a process that we call image assembly and configuration on the device. And then the operating system image is built on the device itself. And in addition, in the tools, you can script. So all your installers and drivers and any other customization that you want to make are scripted as part of this image assembly. So by the time you log on, your image is pretty much done and reproducible fully. Now, one thing I want to note about updates. A lot of times, since we release the product on a DVD and it gets to your hands, Microsoft technology is updated or security updates are released. And you often need to incorporate these updates right off the bat into your image. So there are different ways to do this. You could download all the updates and put them in your development environment and stick them on your image as image is being built. Or after the image is built and you log on, you can go to Microsoft Update and get embedded specific updates and install them on your device, or manually just put updates that apply to your image. There are different ways to do it. And this difference in servicing is also a new scenario that we have enabled in Quebec. Okay, so this slide basically describes what I talked about. I'm going to skip it and talk about embedded core. So what is embedded core? Embedded core is a bootable entity, and it contains all the functionality that's needed to boot to begin with. So it has kernel, it has file system support, and it has all the boot critical drivers. It supports logon. It only supports command line shell, so there is no fancy shell, there is no fancy graphic support. It does support servicing stack, so if you want to install updates, let's say there's a networking update and you want to install it, you can do that on embedded core itself. It contains networking and then some minimal set of APIs that are dependencies of these functions like RPC. Embedded core is interesting because you can just use this to get started with your device. Also, it provides a minimal known platform for testing your applications and drivers. One of the common problems in embedded space, especially with XPE, was that if you built an image and you tested your application on it, and you took that application on another image, there was no guarantee that it would necessarily work because the combination of components that would go in and the versions may override some DLL or something that would interfere with proper operation of your application. Now with eCore, you can be pretty sure that if your application or driver runs within eCore, addition of feature sets is not necessarily going to interfere with your application testing. So there is some thumbs up there. Now, another advantage of eCore is that it's language neutral. So in previous versions of Windows Embedded, there was heavy dependency on English. So if you were building a German device, you always had to have your English resources. You always had to pay the footprint price for English. And sometimes you had fallback languages and so on that made the price even heavier. Now, with language neutral, if you were building a German device, you just stick the German resources on top of eCore, and that's it. You don't need English. There are some languages that still fall back to English, but most of the European language and other common languages are fully localized, or Windows is fully localized in those languages, and you don't need fallback. So once you get embedded core in your image, then you need to pick and choose the feature sets. And now I'm going to explain what I mean by feature set and packages. A feature set is a chunk of OS functionality. Think of it as like Internet Explorer is a feature set, or Windows Media Player is a feature set. Network security is a feature set. Within each feature set, we have looked at, first of all, the architecture of that feature, and excuse me, the size of that feature, and the dependency relationships between that feature, the APIs it exposes, and we've made some calls to break that feature even further. So we haven't componentized every single binary in Internet Explorer, for example, but we have looked at major functionality areas that compose Internet Explorer and the API set that are used by other applications. And we've broken Internet Explorer into 4 packages that I've shown here. The advantage is, if somebody needs to have IE in their image, they can just pull IE. All the packages automatically come in, and they don't even need to bother with picking and choosing the packages. Just pick IE, everything comes in. But if you have an application that's only using, let's say, the HTML rendering part of IE, and you don't even want to have a browser, you just want something that parses HTML, and you use those APIs in IE. And this is the only package that you need. You can just pull that in and not pay the footprint price for the full Internet Explorer. And we also have defined the dependency relationships between these packages, and our tools automatically satisfy the dependency requirements. We also have the concept of optional dependencies. So even if you have IE and you don't necessarily need all the advanced rendering capabilities, you can leave that optional dependency out. Now, in Quebec, we are basically taking Windows 7 and breaking it into eCore and the rest of it into these feature sets that I talked about. We're looking at having an order of about 60 feature sets. Of course, we're not done yet. We're still in development. And our work is going to continue for a while, which would translate to a few hundred packages. And to be honest, I don't really know how many hundreds of packages we'll have. Windows 7 is still in development, and it's going through changes. And we're basically consuming a changing operating system. So we won't be done until Win 7 is out. And right now it's hard to predict, but it will be in the order of hundreds of packages. And one thing to note is each one of these packages that I showed will be signed by Microsoft. It will have configurable settings, and the signed part is different from XP Embedded if you're familiar with the componentization model there. In XP Embedded, you could go and tweak the binaries and resources in a component and create your own custom version of it. But with Quebec, due to security reasons, this is not possible. It is signed, so you can't change the XML file itself. After you install the package on your image, you can go and get rid of binaries and resources that you won't need. The caveat is those binaries may come back through servicing. So to give you an example, if you go and remove explorer.exe from your image because you don't need it, and an update is released that revs explorer.exe, and your system thinks Explorer is installed, that binary may come back with that update. So you have to be careful to not get those binaries back. I mentioned this briefly, but one of the great scenarios that we have enabled in Quebec is the fact that you can add these feature packages post-build and post-deployment. So let's say you build an image, right, and you deploy it in the field, and 3 weeks later you decide that for whatever reason you need to add Windows Media Player to that image. We have tools in Quebec Toolkit that allow you to take these packages and its dependencies and go add them to the image without having to rebuild the whole image and redeploy it. This is often a very popular feature with the OEMs that I talk to. Drivers and language packages. We have taken all the inbox drivers in Windows 7 and turned them into similar packages. So we have pretty much refactored all the drivers based on the IM files, based on the manufacturer. And then in some driver types that we have gotten pretty big packages like printers. Printers are, bring massive amounts of drivers into an image if you just include all the printer drivers. We have broken that down even further based on manufacturer. So we're looking at about, again, 600 to 700 driver packages inbox with the Quebec Toolkit. Like I said, things are still in development, so it may be more, maybe less, we have to see. Driver packages also are language neutral. So if you're installing certain drivers, you can localize the drivers if the driver manufacturer actually has localized that driver. Otherwise, it will be in English. Now, the concept of language pack in Quebec is fairly new. We have taken the MUI resources that are released on Windows and created language packages for those resources. And you can use language packs for localizing your image. So if you're building an image, it is language neutral. If you want to make it English, you can slap English language pack. You can have multiple language packs available on the image and actually online or offline switch between them. And that's a great feature. Our goal is to make language packages available for English, Japanese, Chinese traditional and simplified, German, Italian, French, and Spanish. And I think at our RTM for sure we'll have these language packages. And our target really is, at the end of the day, to have parity with all the MUI languages that Windows 7 releases. Another point is that language packages and drivers can also be installed on the image post-build. So, like I said, if you have a device out in the field, it's English, you decide that, I have German technicians that often go and service these boxes. I would like to have German on my device. You can apply German language pack in the field using our tools to the device. Okay, so let's talk about the toolkit. I've told you a lot about our toolkit and what they can do. So specifically, I'm introducing now the parts of the main tools in Quebec Toolkit. So first tool is Image Builder Wizard. Image Builder Wizard basically runs on a device. It's a wizard experience that builds an image on the device interactively, and I'm going to show it to you later in this presentation. So that is the tool that provides the rapid prototyping experience. Let's say you get this device, you just want to build an image to get going and see what your hardware looks like, and you don't have time to go through the learning and the ramp up of our whole toolkit. You just want to verify something, right? IBW is the perfect tool for you. You just boot your device from a DVD or a USB key, and I'll show you how. And pick and choose the features that you want. It automatically does all the dependency resolution for you, and boom, sometime later you have your image on the device. Now, the next tool is called Image Configuration Editor. Obviously, the IBW is not the experience that all developers need. Once you're done with your learning and prototyping, you want to go into extremes and customize your image, make it reproducible, make it integrate with your version control system. So ICE gives you those capabilities. So ICE basically is a GUI tool that you can go through, save all the feature sets that you want to include in your image, all the eCore settings, all the scripts that you want to run, all the drivers. Save all of that in this XML file. And then next step is to use this XML file to build the image on the device. And at that point, the image build will happen non-interactively. It will not ask you any questions. It will just happen, and you can reproduce it over and over. And for your version control, you can just save that XML file. It's a text file. It's diffable, and works really well in development environments. The next tool is Deployment Image Servicing and Management. If you're familiar with Windows Automated Installation Kit or OEM Pre-Installation Kit, you will see this tool in that kit as well. So this is a tool that we're sharing with them, and it's a great command line tool. It's think of it as the new version of Package Manager. And it does a whole bunch of things. It installs packages, for example, or feature sets online or offline on a Quebec image post-build. So that's the tool that I was talking about that enables all those great installation of language pack and feature sets on images in the field. Windows PE. Windows PE, Windows Pre-Installation Environment. It's a very minimal subset of Windows that basically boots. It has some networking functionality. It can be customized somewhat. And it's a great environment for first boot. I personally often use Windows PE just to boot my box. And then from there, I run IBW or any other tool, or look at the devices that are installed on my box to see what drivers I need and so on. And we're planning to ship that in our toolkit as well. In fact, our product DVD will be a bootable WinPE that you can just put in a DVD player, boot, and start playing with the product. Another tool that is new in toolkit and we're sharing with the desktop OPK is SysPrep. Now, SysPrep is a command line tool. Once you've built your image, you need to generalize it. You need to strip out machine-specific information, capture it, and then put it on your other devices or deploy it in your factory environment. And SysPrep is the tool that does that. Now, SysPrep, the version of SysPrep that we're planning to ship has other interesting capabilities. You can write plugins to not only generalize your operating system, but if you have applications that you need to generalize, you can write plugins for SysPrep that automatically strip the machine-specific information from your application as well. Windows Deployment Services, we're reusing this infrastructure for embedded scenarios, mainly for a remote installation of images on embedded devices. And then we have additional, smaller tools that helps, switching language packs for installing drivers and servicing, detecting what updates really apply to your image, and solving some of the problems that on XP Embedded were very difficult. So, for example, one of the common complaints that we heard on XP Embedded was, well, I've built my XP image, and I know there are a whole bunch of updates available from Microsoft, but I don't really know what applies to my image and what I need to include. And sometimes the process involved a lot of trial and error and testing. So in Quebec, we have tried to solve many of those problems by providing tools that detect applicability of updates to your images and recommend what updates need to be installed. And we've streamlined that through our tools. Okay. So now I'm going to try to go a little deeper into IBW and ICE and actually show you the experience. Now, IBW is the wizard experience that I talked about. It's great for prototyping and fast evaluation. And if you want to go to the advanced experience, you use a combination of ICE and IBW. So here's a pictorial description of these tools. So how do you build your image using Quebec Toolkit? First thing is you create a bootable media. So you stick WinPE in it, or you can use our product DVD. Once you do that, you copy Image Builder Wizard and basically our eCore and feature sets onto that media. Now, we have a new concept in Quebec called distribution share. It architecturally replaces the database that we were using for XP Embedded. So basically, you copy your distribution share into this bootable media. You boot your device with WinPE, run IBW, select drivers, or you can let IBW automatically detect all the drivers and apply them for you. If it can't find some drivers, it will ask you where to get these drivers. And then you log on, and that's it. You install your custom software. If you want to tweak your registry, you can do that. And once you're done with that, you just prep your image, and you can use DISM to capture the image and apply it to other devices or deploy it in your factory. So you could go through this. This would be, in my opinion at least, it would be a fast prototyping experience just to try out the product end-to-end and get the hang of it. But certainly, we have seen that there are mainly two categories of developers in our space. There are some developers that just want to build something and get going. And then there are some developers who have really tough hardware constraints or device constraints to deal with, so they need to customize the heck out of their image. So the first category of developers, if you're in that category, certainly you're welcome to use this scenario. Advanced developers would really use this set of steps. So what they do is they use ICE to generate an XML file that will contain all their selections and customization and scripts that would be run. When you create your bootable media with WinPE, you stick this XML file on that, boot your device, and IBW consumes that XML file and runs automatically on the device. No questions asked. And the rest of the steps are pretty much the same. Okay, so any luck?
You do the log for this machine here? Are you actually getting WinPE?
Yeah, right now I'm on WinPE.
I don't think I know if it's we can try switching that.
It's actually, I wanted to show this one. C. The D is correct. Okay, so why don't I switch the orders, and while they're helping me actually get this box connected, I can show you the ICE experience. So what I wanted to show was really the steps that you have to go through in IBW. And I can talk to it a little bit. So I got this box, which is a typical platform for a mobile thin client. It has 4 gigs of flash and 512 megs of RAM. And it's running with an Intel Celeron processor. And what I got here is basically a USB hard drive. I put WinPE on it. I formatted it, put WinPE. It takes about 3 or 4 steps to do that, and all the instructions are in Windows OPK if you're interested to go check it out. Once I did that, I basically copied our product onto here, and this box right now has booted off of WinPE. So maybe after the talk, if you're curious, if I can't get it projected, you can come and take a look. So once WinPE comes up, all I do is type setup, and it's presenting me a set of screens that I go through. I configure my language, it will detect drivers, and so on. So we'll see how that goes. But with ICE, I get a more advanced experience. So here is, when you start ICE, this is what it looks like. The panes in ICE have changed significantly from Target Designer. Actually, let me ask you this question. How many people have worked with XP embedded in this room? Oh, wow, quite a few people. Okay, so you're all familiar with Target Designer. So the layout may look the same, but the concepts have changed quite a bit. The first concept is, instead of a database, we have a distribution share. And distribution share basically is a folder on your file system. So up here, I've opened the distribution share that's sitting on my laptop. And here's where all our packages are going to sit. So these are all the feature packages categorized. And I can pick and choose whatever I want to add. Out-of-box drivers. So if I have drivers that I want to include in my image, I can add them to that folder. Another concept is eCore. Because eCore is always going to be present in the image, we don't really have a selection step for eCore. eCore just comes up here, and eCore cannot be mutated. You cannot change it. You can't take components out of it or add components to it. It is what it is. However, you can configure it extensively. So all the settings that can be configured on eCore are displayed on this pane. I'm just going to make it a little bigger, and hopefully by RTM we'll have friendlier names, so you won't get a headache when you stare at the list of these components and settings. But if I want to customize any of these settings, all I need to do is add them to my answer file. So a step that I did before was I went to File and clicked on New Answer File, and it basically created a new XML file for me. There are some default things in that XML file. So automatically eCore is added, right? And all these settings have some default values. If I want to change them, I add that change to the answer file, right? Otherwise, you'll inherit the default values from Windows. Let's say I want to add a feature set to my image. So my image is going to have eCore. I want to build a box that just has eCore and Internet Explorer. So I go to Web Development, Internet Explorer. You see all the packages. If I care about the packages, great. If I don't, I'll just add everything to my answer file. Okay? Now, another interesting aspect is when you're building the image, if you remember on XPE, we basically had the concept of FBA, First Boot Agent, and it had all these phases. I think it had about 16,000 phases. And the first 8,000 were reserved for system, and then above that, you could basically insert your own custom actions and applications. So that way you could order what actions you wanted to see on your image. Those phases have been reduced in Quebec because they were very confusing and not many people ended up using them extensively. So now we have divided the installation phases into things that are pretty clear. So for example, when your WinPE is booting, if you want to have customizations there, you can add it to that. Offline servicing, during generalization, you can change settings or run scripts. And during out-of-box experience, you can have customization. And finally, post-logon, you can just run scripts. Now, let's say on Internet Explorer, I want to customize a setting. So on here, I want to customize my start page on Internet Explorer. So I add this setting, and it automatically, every setting knows which phase it goes to. And if there are conflicts, you can actually pick which phase the setting should go to. And on the start page, I can add my own value. So I add MSN and HTTP. Okay, done. All right, so that's all I want to do. Let's see if I can really build this image. Now, at this point, this is the big difference between XP and Quebec. On Target Designer, when I said do dependency resolution and build, my image literally was assembled on my developer box. And then I had to bundle up in some form or shape, maybe do an SDI package, and get it onto my device. This step is different in Quebec. So when I say do image dependency resolution, I'm basically, or in Quebec, we're saying add required packages. This is the step that does the dependency resolution here. So it does the checking, and it adds everything that I needed. So look, all this stuff came in. And I got a bunch of warnings. Let me just increase the size of this pane so you can see. Okay. Oh, so I have a bunch of warnings, and I have an error. Okay, so the error basically is telling me that eCore is requiring a language and some kind of shell, right? So it's telling me that, and I didn't even need to think about that or really remember what IE depended on. So in this case, I want to have a nice shell. I pick Internet or Explorer shell, and I want to have an English. Okay, so I want to point out a few other things. You can actually see the footprint of your image down here as you do dependency resolution. And this footprint is really the size of binaries as best as we can estimate to be on your file system, right? It doesn't include, it doesn't take compression into account. And it doesn't take user data into account. So some of these files, after they're some of these features, after they're initialized, they create, local data or local files that add to your footprint's consumption. At this point, we're not taking that into account, but it gives you an idea of how big your image is going to be uncompressed. Okay, so let's look at some of the warnings. In this case, I told you about optional dependencies. It's basically telling me that the Active Directory feature, which we have broken into multiple packages, had some optional dependencies, and 2 of them are selected. Now, I'm kind of lazy right now, so I'll add just everything in to get rid of the warnings. So this one shows that user profile admin had these resolved must-have dependencies and some optional ones. I say, OK, bring them all in. And this is telling me that now all IE dependencies on core, search, shell, security, and all that is satisfied. OK, done. Just to be sure. All right, my dependency resolution is done. And that's it. So the next step, if I want, I can do a validate step, which basically is validating my XML goodness, if you want, and I'm done. My image is good to go. Now, in this configuration, note that I didn't select any drivers. I only selected a bunch of features and language packs. Automatically, when you run IBW with this XML file, it will automatically run TAP. If you're familiar with XPE, it will run Target Analyzer. It will catalog all the devices that are detected by WinPE. It will map them to the driver packages that we have in box. And if we can't find the appropriate driver package, it will basically show you a screen and says, well, I couldn't find drivers for these devices. Do you want me to continue, or do you want to give me drivers? You can say, oh, get these drivers from from this folder. Actually, if I can get this, I have that scenario. I can show you that I have drivers for the EPC platform on this, and you can just include it really easy in as you're building the image. So that's it. I can just close the answer file, save it. My test image. And if I put it on here and rerun setup, it will automatically consume it and my image will be built. Now, compared to FBA, I mean, how long it will take to actually build the image depends on how many feature packages you have selected and how many installation customizations you have, and how fast your platform is. On this box, it takes about an hour to build the image that I just configured. It's about 1.5 gig image right now. Again, the sizes, don't quote me on it because they could change. It's through development. But I just want to give you a feel for comparing, Quebec to FBA in XP Embedded. Okay, so that's it for my ICE demo. Any luck here?
Try switching over.
Oh, well, it's here. Okay, cool. So I still can't get my IBW demo to work. I'm sorry, should have come here at 8 o'clock in the morning to see it. But this is basically a Win7 embedded image that we've built, and I just wanted to show you. So, all of you have received Win7, pre-beta bits, and you can see the look and feel and the shell and sizes in the current Win7 images. So just for comparison, this is an image that we have built. It doesn't have anything in it except for eCore, Shell, and Internet Explorer. So you see the desktop networking is on. It's pretty clean. There are a couple of accessories, sound recorder, extras, random things. But the shell is very basic, so if you don't really need all the fancy stuff in the shell and you just need the basic interface for your device, here it is. I'm just going to launch IE and play. This is IE8 that comes out. It's connecting to MSN. There's my web page. And I don't know, I want to see how to get a retro look for Halloween. So I click on that video. The sound is working. It's not hooked up. It's fairly good performance. So this has 4 gig of flash, 512 megs of RAM, and fairly slow processor. And in terms of sizes, I think we're looking at uncompressed. So this is my whole image. I think my whole thing with all the Windows temp files, probably a whole bunch of things that I don't need right now, is about 1.2 gigs. And it fits fairly well in the 4 gig. Okay. So I'm sorry I couldn't show you IBW. If you're interested, I can show you later in person, give you a personal demo. And I'm open for your questions and comments and feedback.